this is going to be the big finish for this first section on vectors. And this is a problem involving a weight that's being held on a ramp by a rope. And so the idea here is there is a ramp. I'll try to draw the picture here. So there's a ramp that has an 18-degree incline. And there's a big weight on this ramp that is 500 pounds. So a big heavy weight. Let's see if I can zoom in a little bit. And it's being held by a rope. So there's a rope and then there's a person up here that's holding this weight, okay, with this rope. Otherwise it would just slide down the ramp, wouldn't it? Okay? So now the force acting on this weight here at the moment, if the guy wasn't holding on to this, the force is actually the force of gravity going down. So the weight of this is actually going down like this. And that vector is like 500 pounds. So this probably should have gone down further. Maybe I'll even make it go down further like this. And we'll let this be the 500 pounds. Okay? Now, this question, what it's asking is how much force. Well, first it asks to resolve this into two vectors. Resolve this vector here that's going straight down into two vectors. One that's parallel to the ramp and one that's perpendicular to the ramp. So what it's saying is that there's like a vector here and another vector here that's parallel to the ramp. And this dot should have been up here so that this thing was more up in the center of the weight there. And these two add together, right? These two add together to be this. And so it wants to know how much of this weight, like what's this guy having to pull back on? He's going to have to cancel out the force of this weight that's actually going down parallel to the ramp. Okay? So what we want to do is we want to resolve this vector into these two vectors. The one perpendicular to the ramp and the one parallel to the ramp. How are we going to do this? Okay? So, to do this, what you're going to need here is you are going to need a theorem. And I'm just going to show you real quick. I think I can make this pretty simple here. The theorem here, what we're going to do is just use this first part. It says angles with perpendicular sides are equal. Okay? And this is interesting. I never knew this until I tried to look up this theorem online. So they're going to be either equal or supplementary. We're going to use the fact that they're equal. So what we actually have is we have an angle that is perpendicular to this ramp, right? And then this angle is going to be perpendicular to this. This is the weight going down. So this is the one perpendicular to the ramp. This is the actual 500-pound weight going down. And these two sides are perpendicular to these two sides. And so what it means is this angle is equal to this angle. And it's actually pretty easy to tell that, to see that. Okay, here's how. Since these are perpendicular, those are right angles. And since these are perpendicular, those are right angles. So we have these two triangles, and these are both right angles. Okay? Well, notice that these two angles are equal. And so I put little stars over here. So these two angles and these two angles are equal. And so what it means is that this third angle in the triangle would also have to be equal. Okay, so what that means then is that this here would have the same angle as the ramp here. That's what it means. So, and this is interesting about the supplementary. I don't know if I should have added it, but I never knew this. I knew that the two angles had to be equal if they're perpendicular, but there is a case where they could be supplementary. And the way to show this is if I move this angle over here, so this angle, I'm moving it here like this, and then I'm extending this side. Well, this obtuse angle now is perpendicular to both sides of this angle, but these two angles aren't equal, but these two angles are equal. These two are the same as we had before, so these two are supplementary, so that means this and this is supplementary. So either they're equal or supplementary, basically. But for us, they're going to be equal. Okay, so what this means then is so this angle and this angle, I'm sorry, this is the resultant of these two angles, the parallel and the perpendicular. Okay? And so you could like make your parallelogram like this. So this one and this one are the same. So we don't know what that is, but basically this is going to be a right triangle because this is parallel to this. So and this one is perpendicular to that. This one is perpendicular. This is perpendicular to this. So these are right angles, okay? And then this angle here is equal to the 18 degrees here. So this is equal to 18 degrees, okay? And maybe I could even draw a better picture of this that would make it even more clear. A nice big picture, okay? Let's try to do that. So this is the 500 pounds. And this is the parallel portion. And this is the perpendicular portion. And these are the two components of this. This is the component that's parallel to the ramp. This is the component of this that's perpendicular to the ramp. Okay, and now since these two sides are perpendicular to these two sides, this is the 18 degrees. 18 degrees. This angle here is going to be 18 degrees. And since this and this is the resultant, these are parallel, just like these are parallel. Since these are parallel, then this is going to be a right angle here. And the reason for that is that this is parallel to this, and this is perpendicular. These are at right angles. So those are at right angles. And so this side is your, so 500 is your hypotenuse. This side is your opposite, but this is going to be the parallel side. So I'll call that the X. And this is going to be the perpendicular side. I'll call that Y. Doesn't matter which one you call which. And so, and actually I called them wrongly because this is the hypotenuse. So let me call this one X. You could just use a different name here, and I'll call this one Y. So basically, you get that the cosine of 18 degrees is the X over the hypotenuse, 500. And then you get that the sine of 18 degrees is the Y over 500. Okay, so to get each one of these, the X is just 500 times the cosine of 18 degrees The y is 500 times the sine of 18 degrees. And these are the horizontal vertical components. So 500 times the cosine of 18 degrees. This is like 475.5 pounds. So that's the amount going perpendicular to the ramp. And then 500 times the sine of 18 degrees. And I get 154.5 pounds. And this is then the amount that's going parallel to the ramp. And this is, so the rope is here and the person is holding this up. So this would be the amount of weight that the person here would have to exert in the opposite direction to keep the weight from moving down the ramp. 154.5 pounds. So it's like splitting up into components, but now instead of a horizontal and a vertical component, it's a component that is parallel to the ramp and perpendicular to the ramp. And it's still going to involve a right triangle. So in the next video, I'll give you a setup. We'll set up another one of these, and we'll see if you can find the horizontal and vertical components.